quickly just tell you what you want to investigate. So it is always good that you express your model accurately. So let's go back to some of those things we talked about already. Okay, so Uda asked something in the chat. He said, at what point do we use, he said, at what point does a researcher use structural modeling? Is it structural modeling or structural equation? Okay, structural equation modeling. Yeah. So SEM, or structural equation modeling, is a comprehensive, I would say it's a comprehensive regression analysis. Let me put it like that. Or it's a comprehensive analysis such that it gives you the correlation among variables, it gives you the regression among variables, and even the ANOVA. So here's the thing. If you have several variables, okay, let's say you're using like unit of, you want to see the effect of unit of or factor of production on the performance of a firm. So factor of production, we know it as land, labor, capital, right? So let's say if those are our independent variables, we have three independent variables here: land, labor, capital. And then you want to see how it affects the performance of a business. Regression will simply, as we're going to see, regression will just simply just tell you the effect of land on performance, or the effect of capital on performance, or the effect of labor on performance. But a structural equation modeling will come up with a model that gives you the effect of each of these on performance, while it still gives you the effect of land on capital, the effect of land on labor, the effect of labor on capital. Like it gives you the effect on everything. So it's very holistic. It covers almost everything. If your work is using a structural equation modeling, then you don't need to do regression again. You don't need to do correlation again. You don't need to do ANOVA again. It's a holistic model. I hope that helps answer your question. All right. So when should we use certain things, and what are the signs? So if the purpose of your study is to measure relationship between two variables, like we said, you can use correlation. It can be the Pearson product moment correlation, or it can be the Spearman rank, depending on what you want to achieve. But this is what the model looks like. So you can see child labor, effect of child labor on, relationship between child labor on cognitive development. So if your hypothesis reads to examine the relationship between child labor and cognitive development, do you see the arrow? The arrow is not one-sided. The arrow is going child labor to cognitive and cognitive to child. So it's a two-way thing. For correlation, the arrows are two ways. The arrows are two ways in correlation. How about if you see this kind of model? So I represented it. I hope Martin is here. This is where we have the full explanation of that regression model you asked about. So if the purpose of your study is to examine the effect of a single predictor, this is supposed to be off, of a single predictor, that is the independent variable. I wrote this so that you don't get confused when you see it anywhere. When you hear predictor, please, predictor simply means independent variable. So when they say the regression is to see the effect of a predictor on an outcome, the outcome simply means the dependent variable. Predictor simply means independent variable. All of these are just semantics. They're just statistical terms. They're just the same thing. So it's a simple regression analysis. When you have just one independent variable on one dependent variable. So in our example here, if your hypothesis was to read like there is no significant effects of child labor on cognitive development, or child labor does not have a significant effect on cognitive development. So you can see the key word there is effect. You should know that it is simple regression. Now, remember we said regression is for effect or impact. But here we use simple regression because we only have one independent variable on one dependent variable. So it's different from correlation here where we had one independent, one dependent, but the arrow is two-way. The two-way thing suggests relationship. Here, the arrow is just one, which is, and you can see the arrow is flowing from child labor to cognitive. It's flowing forward from child labor to cognitive. So this tells us effect of child labor on cognitive. So I don't even need to see the purpose of the study. If I just see this and I'm told that this is someone's conceptual model, I'll say, okay, are you trying to investigate the effect of child labor on cognitive development? And the person will tell me yes. Why did I know that? Because the arrow is just one, and then there is only just one variable on one independent on one dependent. So that this is a simple regression analysis. So the simple regression analysis can also be represented mathematically here. Regressions are used to predict. It can be represented mathematically. We have the dependent variable, which is a y. We have the population intercept, which is this b here. We have the slope or the coefficient, which is this beta 1. So sometimes this b here that is called the intercept can be represented as a. We have the independent variable, which is x, and then the error term, which is the e. So this is a mathematical model if you're going to calculate this mathematically. But the point is, regression is the effect is when you're measuring the effect of one independent variable on one dependent variable. How about this? This is still a regression. But this time around, the independent variable is more than one. We still have child labor on cognitive development. But because I can see child labor moving backward to underage working and hawking, it means that underage working and hawking are variables of child labor. Or what we mean by what this researcher is trying to say is that child labor can be broken down into two: underage working and hawking. And then in the same model, I want to see how each of these can affect cognitive development. So a multiple regression will give me both the effect of child labor on cognitive, and it will give me the individual effect of underage working on cognitive and the individual effect of hawking on cognitive. But all in all, it's still to measure the effects of independent variables on one dependent variable. So we said here that the purpose, when the purpose is to examine the effect of more than one predictor, that is more than one independent variable, on one outcome or on an outcome on one dependent variable. So you can see the dependent variable is still one here. When you want to see the effect of different independent variables on just one dependent variable, then your regression, your statistical technique is what? The multiple regression. So if you have hypothesis, let's say you have up to 3 hypotheses, and then you have the first one saying underage working does not affect cognitive development, hawking does not affect cognitive development, uh, volunteering does not affect cognitive development. You can see that in all, cognitive development was constant. It was the dependent variable and it was just the same. It's still cognitive, which is the same. That is, we have only one dependent variable. But the independent variable changed from underage working to hawking to volunteering. If we're going to put it in the same model to see how each of these three interacts with one dependent variable, then it is multiple regression. But if we are going to pick just underage on cognitive and measure, it's simple regression. Okay, Martin, I have seen your hand up. Yeah, ask your question.
Okay, my question is concerning this very uh, conceptual idea you've represented, whereby the child labor is uh, has two subsets. Now, my question is, what if this arrow that connects the child labor to underage working and hawking is reversed in such a way that the arrowhead rather points towards child labor and that of hawking points towards child labor likewise? Would that be out of order? In other words, the implication might be that underage working and hawking are subsets of child labor, which may directly affect cognitive development. Would that be out of order?
Okay, you mean if the arrow that is pointing from child labor to underage working is rather
Is
pointing from underage to child labor?
yeah.
Once the arrow is pointing forward, it means effects. So that if this arrow if this arrow that is here changed to, the direction is now from underage to child labor, it will now mean, if I want to reinterpret that, I will say underage working affects child labor, and then child labor in turn affects cognitive development. You're going to see a situation like that. But this that is showing from child labor to underage backward is trying to tell us that these are subsets, or these are elements of child labor.
Oh, okay. Because I've seen a situation whereby the arrow actually points on the reverse direction and the meaning was different.
Yeah,
I
once
think
we are saying the same thing. Once the arrow points in that different direction, the meaning will change. So we want to be careful about how we are putting our arrows. If I change this arrow from underage working to point towards child labor, it means what the researcher wants to investigate is the effect of underage working on child labor, and then the effect of child labor on cognitive development. So it's like what we call the mediating variable. It's like saying that child labor mediates the effect of underage working on cognitive development, so that underage working passes through child labor and then passes through cognitive. But from what is represented here, this means that you can now see that this arrow is pointing backwards, not forward. It means that these two are subsets of child labor. So once the arrow changes, the interpretation will change. You want to be careful how you place your arrow.
thank you. It's clear.
All right. So this is another one. How about if cognitive development was broken down? You know, how about if cognitive development was to the researcher, cognitive development meant classroom learning ability and then the real world learning ability. And then the person wants to see how child labor affects both learning ability. So you can now see that the dependent variable here is more than one. The dependent variable is more than one. All this while we've been looking at the dependent variable being one, and then the independent variable either being one or being multiple. But now the dependent variable is more than one. That is, there are two dependent variables here, or there may be more dependent variable. In that case, when your study is to examine the effect of one or more predictors, that is one or more independent variable, on more than one outcome or dependent variable, once a dependent variable is more than one, then you go for a bigger estimation. That is the maneuver. Maneuver means multivariate analysis of variance. Multivariate analysis of variance. So this equation, sorry, I have to take this off. This equation is not right. The equation comes like a matrix. Maneuver is multivariate analysis of variance. When you have more than one dependent variable. So let's say your research hypothesis reads like this: to examine the effect of child labor on classroom learning ability, and to examine the effect of child labor on real world learning ability. You can see the dependent variable is 2 here, but child labor was the same, but the dependent variable became more than 1. You use what is called multivariate analysis of variance. So you can have different independent variables on different dependent variables. But if it's going to be in the same model, and then your dependent variables are more than 1 in the same model, you have to use what is called multivariate analysis of variance, not regression, if you are going to use it in the same model. Have you seen a topic where you see something like moderating effects? Maybe there's a topic and then they tell you the moderating effect of something. Great. When you have a moderator, there's something called a moderator. So in this case, let me say from this diagram we can see here, if I'm to interpret this, if I'm to give this a topic, okay, I don't have the topic here, but if I'm to look at this diagram and give it a topic, this is telling me that the person wants to see the effect of child labor on cognitive development, but there is something that is in between that effect, and it's called location. So I get the sense that the location here is a moderator. It's moderating the effect of child labor on cognitive development. So if I want to give this a topic, I will say the effect of child labor on cognitive development, column, the moderating effect of location. Like I want to examine the moderating effect of location. So the moderator is just it's like an external variable, okay? It's not really, it's somehow considered an independent variable because it's independent on its own. It's independent on its own, but it's an external variable that can just have some, play some kind of role on the real variables you want to study. So in this case, child labor, our interest was to see how child labor affects the cognitive development. But now I want to see locations such that if this child was in the urban location, is it really going to affect his cognitive development? Or if this child was in the rural development, was in the rural location, would there be a difference between that labor on his cognitive development? So once location has been brought in and is presented like this, it tells us it's a moderator. You can use two kind of statistical technique for that. You can use the hierarchical regression if it's a regression that is your main analysis, or you can use partial correlation for that. What if you have a mediator? So there's something called moderator, and then there's something called mediator. The mediator comes in between the independent variable and the dependent variable you want to study. So it can be presented as you can see in A here. It shows that child labor can be affected by, and it can affect the location, and then can affect cognitive development. So this is what this is saying. It can also be presented this way. Actually, this B is the right presentation if you ask me. Because first, it shows you the real thing you want to investigate, the effect of child labor on cognitive. Then it shows you the effect of child labor on location, and then location on cognitive. So this B is actually the right way to present it, but A is still accepted. The statistical technique you use to check for a mediating effect of a particular factor, location being the factor here, is Sobel's test. Remember that I said unless you want to go through a full data analysis class before you can really understand all the assumptions for each of these tests. But this bootcamp is to help you understand what your research question is, what you want to investigate, so that if you eventually have to outsource the analysis, the data analysis, you should know what to expect. All right, so that is it. And before you just go ahead to test for hypothesis, especially when you're using inferential statistics like regression, for example, it's good practice to clean your data, to screen your data, to check that all the assumptions are met. So here are some basic or some necessary preliminary tests you have to perform on your data before you run an actual regression analysis, especially if that regression is multiple regression. This is what you have to do. You have to first check for non-response bias. To check for non-response bias, you can use the Brown-Forsyth test or the Levin's test. Then next, you check for missing data. Sometimes people fill your questionnaire and then they leave spaces. There are some questions they don't fill. When you want to impute it, as you're going to see on the SPSS day, when you want to impute it in the data set, that place will be empty. It's called missing data. Missing data can affect your analysis. So you check for missing, you do a missing data analysis, and then either use series mean to cover up for it. You also do a descriptive analysis and descriptive statistics like frequency, mean, median, percentage, minimum, maximum. Then you check for outliers test. You check for normality. You check for linearity. You check for what is called homoscedasticity. You check for serial correlation. You check for multi-correlation, multicollinearity. Multicollinearity and serial correlation they almost go hand in hand. Then you do a validity test too, which is like yeah, the factor analysis thing. So the validity test can come before all of this. Like if you're going to do a pilot study, you can do a factor analysis, or you can just do a content and construct validity like we showed when we talked about method. And then you run a reliability test. Once your variables are reliable and you've met all these assumptions, you can run your regression. So if you want to do a very good job, yeah, you have to do all of this. So there's a sample that has been sent of a work that used everything, that did everything, so that I see what it looks like. If you're interested in a data analysis class, then you have to come differently for that. How do you present your data? Well, data presentation can be done in the form of the preliminary section, which is just going to be the descriptive, the trends of the variable, how many people responded, what the response was like. Then the data cleaning test, where we had all those normality, linearity, homoscedasticity, heteroscedasticity, autocorrelation, all those plenty. It's quite a lot. So you need to have all of that. Then before you present the regression itself. So it's also good there's a hint here. If you want your work to also be considered easily for publication, don't just present all these things in tables, or don't just fill your work with a lot of tables. Try to make use of charts, plots, graph. If you want to use tables, make it very comprehensive and beautiful. So Excel can do that, Tableau can do that, R can do that. So we're going to learn about R on Thursday and how to do it. So visuals are appealing and they help to bring your data to life. I'd like to say there's one of a study that I submitted to a journal, and the visual that I was this what do you call that plot? Not the box plot. There's a particular plot I use. The Splum charts. Yeah, it's called the Splum chart. So I use the Splum chart, but at first I'd send that work to another journal without the Splum chart. It wasn't accepted. But when I brought in what is called the Splum chart to it, I mean, it's still the same thing by presenting mean, but I presented the mean using a chart this time around called the Splum chart. It was accepted because not many work make use of this kind of presentation. It was accepted. So your descriptive can look like this. It's not until you have so number of people agreed or disagreed. You can just have your descriptive this way. You put your variable, how many people responded to it. That's your observation. What was the standard deviation like? What was the mean like? Just present it at once like this and save yourself the chase of strongly agreed, disagreed. You're going to see that in the sample that was presented. These are what some figures can look like. So this is a histogram. I could have still presented this like a table showing the mean, standard deviation, the number of people of elements, But with this histogram here, someone can just look at it and say, oh, this this data is normal. So this is showing normality to some extent. Once the curve is like this, very normal, you can see that it's not tilting to the left or it's not tilting to the right. It's in the middle, sort of. Then it's the data set is normal. This is what it's telling us. So I save the reader the strength of going to read through figures to understand whether the data set is normal or not. This figure has said it all. A scatter plot. So this is what a scatter plot looks like. The scatter plot has its own definition, is also used to know whether your variables are widely dispersed or whether they are all that whether you have different, whether the responses vary, or whether you have all of them saying the same thing. If you have all of them saying the same thing, your scatter plot will likely be all these dots will likely be in a particular position, and then you have a high risk of multicollinearity for your study. So this is showing the reader, or this is showing the audience, that I do not have multicollinearity in my study because my responses, or the responses for my survey, are well dispersed. All right. So we know this is quite technical, but that's where we end this lecture for today. Questions, reactions?